So this is my third video lesson for the unit atomic theory. Today we're going to talk about the charge of an ion. How do we determine it? Let's go to page 9 in the class packet. For motivation, what is the charge of an atom if the atom lose electrons or gain electrons? So try this yourself, pause the video and resume once you have the answer. So electrons are negative. If you lose something negative, you become positive. So the atom will be positive. If you gain something negative, you will become more negative. So if you gain electrons, the atom will be negative. Learning target. At the end of the lesson, I'll be able to determine the charge of an ion. Announcements. So homework number 3 will be a Junopod. There'll be a quiz Junopod based on what we covered so far in this unit. So here are two new terms, ion, isotope. So they are used to describe an element with varying neutrons and electrons. If it's varying by electrons, we call it an ion. It's basically an element with different number of electrons. So it will be a charged particle. An isotope, on the other hand, will vary by neutrons. It's an element with different number of neutrons. Because of different neutrons, it will have different mass number or mass. So here's an example of ion. We have magnesium ion with a positive 2 charge. It lost 2 electrons. With oxygen with minus 2 charge, it means it gained 2 electrons. Here are some isotopes. So here are carbon isotopes. So since it has different neutrons, the mass numbers are different. We have carbon 12, carbon 13, carbon 14. Check of understanding. Do you think isotopes of the same element have the same or different properties? So we'll come back to this in the nuclear chemistry unit, but the answer is different. They have slightly different properties, right? Because of the extra neutron. Some of these might be radioactive, right? Carbon 13 is used for dating. So slightly different properties. So keep that in mind. So turn and talk. What do you notice about the chemical notation that differentiates ions and isotopes? If you notice, the isotopes change by the mass number, while the ions change by the charge. So the mass number is on the top left side of the symbol, while the charge is on the top right side of the symbol. So here's a model of the atom. When the protons equals electrons, we say the charge is neutral. But for ions, they have either more electrons or less electrons than the number of protons. An ion is basically a charged particle. Atoms become ions by gaining or losing electrons. So now we're going to go over the two types of ions, the negative one and the positive one. Let's start with the negative one. Anion is when an atom gains electron to become negative. We call it an anion. The number of protons is less than the number of electrons in the atom. One easy way to remember this, notice the word anion has the word ion in it. The prefix "an" stands for something negative. For example, anarchy. Anarchy is a negative thing. It's bad. So if you put it together, this means negative ion, literally. So now let's compare the sizes of the atom and the anion. So on the regions, whenever you see the word compare, it means is it bigger or smaller? You don't have to explain it, okay? Just say if it's bigger, smaller, or the same. So based off these pictures, it is bigger. As atoms gain electrons, they become bigger. In the future, we will explain why that's the case. So the second type of ion is the cation, which is the positive ion. When atoms lose electrons, they become positive, right? They become a cation. So the number of protons is greater than the number of electrons. Now let's do the same thing and compare the pictures of the atom and its corresponding cation. So as atoms lose electrons, they become smaller. So this is how I used to remember cation as a positive ion. The cation has a T in the word, which looks like a plus sign. So it is good to develop strategies to help you memorize terms, because a lot of science terms mean something, and then there'll be another term that is the opposite of that. So if you don't develop any strategies to help you memorize science terms, it's very easy to confuse the two on exams. So here's a summary slide of what we covered so far. So we know an ion is an atom with a charge. An atom itself is neutral, right? And when it gains or loses electrons, it becomes an ion. So there's two types of ions, anion, which is negative, and cation, which is positive. So how does an atom become a cation? It loses electrons. How does an atom become an anion? It gains electrons. Why do you think an anion is bigger and a cation is smaller? We will cover this in the next unit, but for now, let me just give you a couple of answers. So when you gain an electron, you may fill another shell, which causes more electron repulsion. If you lose electron, you may lose a shell, and since there's less electron repulsion, electrons are drawn closer to the nucleus. So here is how you can calculate the charge quickly. Charge is equal to the number of protons minus the number of electrons. So here is an analogy to help you remember that when atoms gain electrons, they get bigger. When atoms lose electrons, they get smaller. Think of a guy that's gaining or losing weight. If the guy is gaining weight, he gets bigger. If the guy is losing weight, he gets smaller. Learning trick number 1. An ion that consists of 8 protons, 8 neutrons, and 10 electrons has a net charge of. So pause the video and try these yourself. Okay, so charge is equal to the number of protons minus the number of electrons. So 8 minus 10 is negative 2, choice 4. What is the total number of electrons in magnesium 2 plus ion? So try this yourself, pause the video, and resume once you have the answer. Okay, so we're given the charge, but notice we're not given the number of protons. You have to look it up. What is the atomic number of magnesium on the periodic table? It is 12. Now you plug it into the charge equation. If you do that, you should get the answer as 10. Okay? Because 12 minus 10 is 2. Learning trick number 3. What is the number of electrons in an atom that has 20 protons and 17 neutrons? So try this yourself, pause the video, and resume once you have the answer. So the key word here is atom. Remember, atoms are assumed to be neutral unless stated otherwise. So since this atom is neutral, that means it must have 20 electrons. Choice 3. Okay, so here is a number line to help you remember. So this way is positive, this way is negative. So neutral is in the middle, okay? So the atom is assumed to be neutral. If it has more electrons than protons, the atom is negative and we call it an anion. If it has less electrons than protons, then the atom has a positive charge and we call it a cation. Okay? So neutral is when protons equals electrons. So now we're combining on what we learned in the last PowerPoint. Charge is usually placed on the top right corner of the symbol. Okay? If the charge is 0, then it is left blank. You don't have to put a 0 here if the charge is 0 or if the atom is neutral. So over here, this fluorine is neutral. Learning trick number 4. So here we're given sodium. How many electrons does the sodium have? Pause the video and try to do it yourself. Okay, so here's the answer. So sodium has a positive 1 charge. What's the atomic number of sodium? Look it up on the periodic table. It is 11. Okay, so how many electrons would the sodium have with atomic number of 10, which is the number of protons, and the charge is 1? So the answer, if you work backwards, is 10, choice 2. Because 11 minus 10 will give you 1. Then check number 5. Here we're given nitrogen. How many electrons does this nitrogen have? Try to do this yourself, pause the video, and resume once you have the answer. Okay, so nitrogen has a charge of minus 3. What is the atomic number of nitrogen? It is 7. And since the charge is negative, we have more electrons than protons. So if you work backwards using the charge equation, that should give us 10, choice 4. So now I want you to take a moment to figure out the charge given the protons and electrons. Pause the video and try this yourself. Okay, so here's the answer. So here's a summary slide. So P is protons, E is electrons. Okay, so now let's answer these questions. So remember, as a priority, always use the information that is given first. As a secondary, if no related information is given in the question, then use the information from the periodic table. So here we have carbon. What is the number of protons of carbon? It is 6. Notice that the charge is -4. So if you work backwards using the charge equation over here, you should get the number of electron as 10, which makes sense because we have more electrons than protons. That's why the charge is negative. For the neutrons, you have to use the mass number. Okay? So if you work backwards, you should get 6 as the number of neutrons. The atomic number is the number of protons. So for carbon, it's always going to be 6. For the atomic mass, it is not given on the chemical notation. You have to look it up on the periodic table. If you do that, it is this. And the charge of this carbon is -4. Now I want you to try to do the same for oxygen. Pause the video and resume once you have the answer. Okay, so here's the answer for oxygen. So here in this practice problems, you are given the chemical notation and you need to determine the number of protons, electrons, and neutrons that this atom has. So I'm going to do the first one and then you can do the rest on your own. So here we're given chlorine. You got to go to the periodic table and look up the atomic number of chlorine. That is 17. Notice that the charge is positive. That means we have less electrons than protons. We have 1 less because the charge is 1. So for neutrons, you gotta look at the mass number. So 37 minus 17 is 20. So now try to do the rest on your own. Resume the video once you have the answers. Okay, so here are the answers. So for part 2 of the practice, this time I'm giving you the number of protons, neutrons, and electrons. You are going to write out the chemical notations. So pause the video and resume once you have done part 2. So here are the answers.